Welcome all of you. I am Rosalind Mishra. Welcome to our class of Pharmaceutical and Organic Chemistry. So, we shall continue with our Unit 4 today again. This would be our last topic in Unit 4, which is astringents. Okay. So, we shall be learning about astringents, about what is meant by astringents, about mechanism of action of astringents, what are the various uses of astringents, along with two specified drugs which has been asked in your syllabus, that is zinc sulphate and potash alum. Zinc sulphate and potash alum. Okay. So, now moving on forward, astringents. What is an astringent? Well, an astringent, sometimes also called as astringent, is a chemical that shrinks or constricts the body tissues. Okay. They have shrinking or constricting effect on the tissues of our body. They precipitate the protein. They lead to protein precipitation. They also form protective layer on the surface of our body. They also form protective layer on the surface of our body. This word astringent derived from the Latin term astringere. It is derived from the Latin term astringere, which means to bind or to bind fast. For example, calamine lotion, witch hazel and yerba mansa. It is a Californian plant. These are the various common examples of astringent. So, what are astringents? They are chemicals that shrinks or constricts body tissues. They also precipitate protein and form a protective layer on our body. Okay. So, these are the various uses or these are the various characteristics of an astringent. Here we have a list of commonly known astringent, which is calamine lotion, witch hazel and yerba mansa. These are the commonly known astringents. Now, due to their protein action, astringents are able to reduce the cell permeability. They bind with the proteins. Astringents have the capacity to bind to the protein, hence reducing the cellular permeability. Okay. These reduce local edema. Astringents also reduce local edema. Edema also known as swelling. They also reduce exudation. They also reduce inflammation. Okay. So, these are the various uses of our astringents. Number 1, they reduce local edema, they reduce exudation and they reduce inflammations. They are usually applied to damaged skin topically or to the mucous membranes of gastrointestinal tract, including the mouth. Okay. So, where are the astringents applied? What are the areas where astringents show their action? They are applied to the damaged skins. As we already said, that astringents are used as a protective layer. Okay. They are used as protective layer. Hence, they are applied to damaged skins topically. Okay. That is to the mucous membrane or to the GIT or to the membranes of the mouth, internal membrane of the mouth as well, or the oral cavity. Astringents are usually classified into 3 groups. Okay. Based upon their mode of action, astringents can be classified into 3 groups, 3 categories. Number 1, those that decrease the blood supply by narrowing small blood vessels. See, very simple to understand. Astringents are used for constriction. They constrict the tissues, isn't it? So, hence astringents are used to decrease the blood supply by narrowing the small blood vessels, by constricting the small blood vessels. Hence, they are used for stopping excess blood loss. Astringents constrict the blood vessels, they constrict the narrow blood vessels, due to which excessive blood loss could be stopped or prevented. For example, epinephrine and cocaine. These are few astringents which are used for inhibiting or stopping excessive blood loss. The other category of astringent include those that abstract water from the tissues. These are the astringents that remove out or abstract water from tissues. Example, glycerol and alcohol. They are also known as dehydrating agents. They are also known as dehydrating agents. They remove alcohols from the, they remove water from the tissues. The third category of astringent belongs or can be defined as the ones that coagulate the superficial tissue layers into a crust. They coagulate protein. They coagulate tissue protein into a crust-like material. Example, metallic astringents such as calamine or alum. Okay, so here we have seen the major classification of astringents. Astringents can be classified into three major categories. Astringents are classified into three major categories. What are they? Depending upon their mode of action, astringent can be classified as first category, those that decrease the blood supply by narrowing the blood vessels. First category, these astringents decrease the blood supply by narrowing the blood vessels. For example, epinephrine and cocaine. This activity they do via their constricting action. Okay, these are used as constrictors. The second activity is they abstract water from the tissues. Okay, that is they act as dehydrating agents. Astringents also act as dehydrating agents where they abstract water from the tissues. The next example of these agents are glycerol and alcohol. Glycerol and alcohol. The third category being those that coagulate the superficial tissue layers. They coagulate proteins. Okay. The third category of astringent belong to the category of coagulation of proteins, forming a crust. Example, metallic astringents such as calamine and alum. How do they do this? How do they do this activity? See, skin is made up of two layers, lipid plus proteins. Skin is made up of lipid and proteins. Proteins are in turn made up of peptides. Proteins are in turn made up of peptides or amino acids. Okay. So what happens here is, are constituent of the skin atoms which are capable to form metallic bonds, that is chelate of metals with proteins. Okay. So what happens here is, our astringent, especially metallic astringent, they chelate with the proteins. They form metallic bonds. They form metallic bonds, also known as chelation. Also known as chelation. Okay. So what happens here is, our astringent, metal containing astringents form chelates with proteins, with those proteins that can form chelation, especially sulfur containing proteins. They bind with these proteins and form chelates Okay. So this is how an astringent binds with the skin. Here we have understood that astringents coagulate the superficial tissue into a crust. Okay. How do they do this? By coagulating the protein. How do they coagulate the superficial tissue? By coagulating the protein. How do these astringents coagulate the protein? The metal present in this astringent forms metallic chelate with these proteins, hence forming a coagulate or crust, thus forming a crust on the superficial tissue. Now moving on further, we look into various characteristics of astringents. When we talk about various characteristics of astringents, Well, astringents affect only the superficial layer. Okay, astringents affect only the superficial layer. Clear all of you? They are not meant to act inside. They reduce cellular permeability because they constrict the blood vessels, they constrict the tissues. They are used for reducing cellular permeability. They make the surface mechanically strong by decreasing exudation. Okay, so what are the characteristics of astringent? Number one, they affect only the superficial layer. Most important characteristic, affect the superficial layer. Number two, they affect the cellular permeability. They affect the cellular permeability, yani cell permeability to fluids. They make the surface mechanically strong. Astringents make the surface of the tissues strong. They decrease exudation. They decrease exudations. Okay, astringents protect the tissues from external irritation as well. Astringents have protective action on the tissues. They protect the tissues from external irritation. Next, they possess local styptic and antiseptic action. A very important characteristic of astringent is they show antiseptic activity. They have a local styptic and antiseptic action. Astringents may interfere with the function of pain receptors. Okay, astringents might interfere with the function of pain receptors. The pain relieving action is mild. See, they have a slight pain relieving actions, thereby hindering the function of pain receptors. Next, they constrict the blood vessels to stop bleeding. This is another function which is of utmost importance to us. They are used to stop bleeding. Okay, so this is a very important activity, that is they can prevent excessive blood loss. These agents can prevent excessive blood loss by stopping bleeding. We've already discussed earlier, astringents are used for constricting small blood vessels. So apart from these characteristics, we shall move on further towards discussing the classification of astringents. See, when we look into the different classes of astringents, they include vegetable astringents. Okay, vegetable astringents. Yani, these astringents are derived from vegetable sources or plant sources. For example, tannic acid and gallic acid. Metallic astringents like aluminium salts, which is also known as alum, aluminium chloride, aluminium acetate. Okay. So, astringents are divided into two major categories. Number one, vegetable astringent. Number two, metallic astringents. Vegetable astringents are obtained from plant sources, and metallic astringents as usual are obtained from inorganic sources, namely aluminium salt. First example, aluminium salt. Aluminium salt occurs in the form of alum. Okay. It also occurs in the form of aluminium chloride. It also occurs in the form of aluminium acetate. Aluminium acetate. Apart from this, chemical astringents or metallic astringents are available as zinc salts. Example, zinc chloride, zinc sulphate. Metallic astringents are also available as ferric chloride. It is also available as ferric chloride. Strontium chloride, silver nitrate, copper sulphate, alcohol. These are various other categories of astringents. So, astringents can be classified into two major categories, namely three major categories: vegetable astringents, metallic astringents and miscellaneous. Under vegetable astringents, we have tannic acid and gallic acid. Under metallic astringents, we have aluminium salts, zinc salts, ferric chloride, strontium chloride, silver nitrate, copper sulphate and miscellaneous. Under miscellaneous, we have alcohol as one of the astringents. Okay, so till now we have discussed about what astringents are, what are the classifications of astringents, and what are the characteristics of astringents. So what are astringents? They are chemicals that shrinks or constricts body tissues. What are astringents? These are chemicals that shrinks body tissues. They precipitate the proteins. They are responsible for protein precipitation. They are responsible for shrinking of body tissues. They are responsible for protein precipitation, and they form a protective layer on the surface. Astringents can be classified into three major groups. Okay, we shall just have a brush up and then we will look into the examples of astringents. Okay, so astringents are usually classified into three major groups according to their mode of action. So according to the mode of action, how can astringents be classified? Number one, those category that decrease the blood supply. Okay, those astringents that decrease the blood supply. How do this blood supply get decreased? By narrowing the small blood vessels. Small blood vessels are narrowed, due to which there is a decrease in blood supply. Example, epinephrine and cocaine. The other category is those that abstract the water from the tissues. These are the astringents that remove or leads to dehydration of water, or they lead to dehydration of tissues, that is removal of water. For example, alcohol. The next category of astringent belongs to the one that coagulate the superficial tissue layer. That is, these metallic astringents form chelates with the proteins in our tissue. Okay, hence leading to formation of a superficial tissue layer or a crust. So these are the activities or mode of action by which an astringent shows its effect. Now we shall move on further to look into uses of astringents. In medicine, astringent cause constriction or contraction. In medicine, astringents are responsible for contraction or constriction of mucous membrane and exposed tissues, and are often used internally to reduce the discharge of blood, serum and mucus secretions. Okay, so in medicine, these astringents are used for contracting or constricting the mucous membranes. Mucous membrane or other exposed tissues. Next, they reduce the discharge of blood, serum and mucus secretions. These also reduce the discharge of mucus and blood. Externally, this can also be used in the cases where sore throat and hemorrhages, diarrhea and peptic ulcers. See, astringents, apart from the upper examples, can also be used in various other cases. Cases where there is a sore throat, astringent can be given. They are used in hemorrhages. They are used in cases of diarrhea and peptic ulcers. These are the various other uses of astringent. Next, externally applied astringents which cause mild coagulation of skin proteins. They cause dryness and harden and protect the skin. Okay. So these are the other uses of astringents, wherein if externally applied, astringent cause mild coagulation of skin proteins. Clear all of you? If applied externally, astringents leads to coagulation of skin proteins. They lead to drying and hardening of the skin. These are the other uses of astringents. The first one being, when applied, they reduce the discharge of blood, serum and mucus secretions. They reduce these discharge and secretions. Number two, they are used in the treatment of sore throat, peptic ulcer, diarrhea and hemorrhages. Apart from this, when externally applied, Astringent cause mild coagulation of skin proteins. People with acne are often advised to use astringents if they have oily skin. So, astringents are used for treating oily skin also. Mild astringents relieve minor skin irritations, those that results from superficial cuts, allergies, insect bites and hemorrhoids. Okay. So, these are the other uses of astringents. Now, we will look into individual astringent in detail. We shall study zinc sulphate first. Okay. Zinc sulphate, also known as white vitriol. Zinc sulphate, also known as white vitriol. It has a chemical formula ZnSO4.7H2O. It has a chemical formula ZnSO4.7H2O. It has a molecular weight 287.6 gram per mole. Okay. Zinc sulphate, also known as white vitriol, has a molecular weight of 287.6 gram per mole. It belongs to the category of astringents. Now we will see the preparation of zinc sulphate or white vitriol. Zinc sulphate is prepared by heating zinc sulphide in the presence of an air under specified conditions. The heated mass is dissolved in hot water first. Zinc sulphide heated mass is dissolved in hot water. It is filtered and the resulting solution is concentrated to get the crystals of zinc sulphate. Okay. So, zinc sulphide ZnS at high temperature is dissolved in water. It is then filtered and the resulting in the presence of oxygen. Zinc sulphide in the presence of oxygen at high temperature and water is converted into zinc sulphate ZnSO4. The resulting solution is then concentrated to get the crystals of zinc sulphate. Since zinc sulphide is first dissolved in water, the resulting solution is diluted form, so it is concentrated first, then the crystals of zinc sulphate is obtained. Now we will move on towards studying the properties of zinc sulphate. Zinc sulphate is a white powder or white granular mixture in nature. It is odorless. It is odorless. It has got an astringent and metallic taste. The density of zinc sulphate, when we look into anhydrous zinc sulphate, it has a density of 3.54 gram per centimeter cube. Zinc sulphate heptahydrate has a density of 2.072 gram per centimeter cube. The melting point of zinc sulphate is 680 degrees Celsius. It decomposes. Anhydrous zinc sulphate has a melting point of 1000 degrees Celsius. Zinc sulphate heptahydrate 100 degrees Celsius. Zinc sulphate heptahydrate has a melting point of 70 degrees Celsius. When we look into solubility in water, 57.7 gram per 100 ml of solubility is shown. Zinc sulphate is soluble in water in the ratio of 57.7 grams per 100 ml at 200 degrees Celsius. The refractive index of zinc sulphate is 1.658. 1.4357 is the refractive index of zinc sulphate heptahydrate. Zinc sulphate is a colorless, transparent crystal. It is colorless and transparent in nature. It is in the form of a prism or needle crystalline powder. They are odorless with a metallic and astringent taste. Zinc sulphate is used externally in the form of solution and powder as an astringent. When used internally, it acts as an emetic which causes vomiting. Now moving towards potash alum. Potash alum, also known as alum, has chemical formula KlSO4 twice dot 12H2O. Okay. It has a molecular weight 474.4 grams per mole. It belongs to the category of astringents. They are white, crystalline, double sulfates of univalent and trivalent atoms. Okay. These are white, crystalline, double sulfates of univalent and trivalent atoms. Alum is both a specific chemical compound and a class of chemical compounds. Okay. How is an alum prepared? It is prepared by adding concentrated solution of potassium sulfate to a hot solution of equivalent molar proportion of aluminium sulfate. Okay, so potassium sulfate, equivalent molar solution of aluminium sulfate in the presence of water gives KlSO4 twice dot 12H2O. This forms KalSO4 twice dot 12H2O. When the solution is concentrated and cooled, characteristic octahedral crystals of potash alum is separated out. Octahedral crystals of potash alum is obtained out. These are colorless, transparent, crystalline structure. It readily dissolves in water, and the solution thus obtained is slightly sweetish in nature. It is acidic in nature, and an alum powder solution turns litmus paper red. Okay, due to the acidic condition, it changes the litmus paper red. On heating, alum powder changes to liquid first, and if it is heated further, then it swells up to form froth. Potassium alum is mainly found in the Andes mountain in South America, in Bolivia, Argentina and Chile. In United States, alum crystals are found in Tennessee, Nevada and Arizona. When we talk about uses, alum is used as an adjuvant in many subunits vaccines such as hepatitis A, hepatitis B, diphtheria, tetanus, in order to augment the body's response to immunogens. Alum has a strong antibacterial property, and so it is useful as a natural deodorant by inhibiting the growth of the bacteria responsible for the body odor. Okay, so these are the major uses of alum, wherein first it is used as an adjuvant, second it is used as a strong antibacterial agent in deodorants. Alum is listed as an ingredient of toothpaste or tooth powder and pharmaceutical aid. Alum also acts as a styptic to contract organic tissues and stop or reduce hemorrhage and bleeding. It is also used as an emetic agent to induce vomiting when a person has swallowed poison. So with this, we end our unit 4. I'm sure, I hope the lecture was useful to all of you. Thank you.